Welcome everyone to this series of videos dedicated to presenting the DSAnalysis Matlab Toolbox. This is Philippe Derua talking. I have written a PhD thesis called Model Transformations and Periodic Trajectory Calculations for Stability Assessments of Modular Multi-Level Converter-Based Systems. And the DSAnalysis Toolbox relies on this PhD thesis. So there are a number of things you can do with this toolbox. I will just read the options with you. Definition of dynamic systems by means of analytical differential equations in state space form, their numerical parameters and inputs. The calculation of periodic trajectories or equilibria. The symbolic linearization of the analytical differential equations in state space form. Also the transformation of time periodic systems into linear time invariant systems, that is done by means of a transformation called frequency lifting. Next, the calculation of eigenvalues and or characteristic roots, which enables the small signal modal analysis. This includes participation factor calculations. The calculation of frequency responses, which in turn enables frequency domain stability assessments. And lastly, the numerical integration of the differential equations, which is equivalent to time domain simulations. This web page is part of the HVDC research portal of the ELECTA research group in the electrical engineering department of KU Leuven. There is a user manual that is also available with the toolbox. In particular, the user manual has a section called Getting Started. This is what we will follow in the beginning to understand how to install the toolbox and how to run a first example. In particular, to use the toolbox, we will need Matlab. The version on which I have been working is Matlab 2021b. Normally, the toolbox will work on other versions of Matlab. However, it is possible that a few features specifically depend on using this version of Matlab. Also, Matlab alone will not be sufficient. You will need the optimization toolbox of Matlab and the symbolic math toolbox of Matlab. Once you have downloaded the DSAnalysis folder from GitHub, you can extract it if needed, and then you will obtain this folder structure. We have subfolders called Code, Docs for documentation, SSTMs, which stands for systems, as well as files, which are the main file, a file to create a new project, as well as the license. In the docs subfolder, you have access to the user manual, as well as to my PhD thesis and links to reach the HVDC research portal of the ELECTA research group. So according to the Getting Started section, we need to set the DSAnalysis folder as the current Matlab path. So this is what I have done here. I am working inside the DSAnalysis folder, and if I want to open a file from here, this is what appears. So we are indeed working in the DSAnalysis folder. And then lastly, the Getting Started section suggests to open the DSA main file, and then we will be ready to run an example. Before going further, I will introduce a very simple dynamic system, which we will use as support to guide essentially the description of the toolbox. So this is my PhD thesis, and going to chapter 5, chapter 3, we will have this very simple RLC circuit. This circuit has a voltage source with a Vs as input variable. It has a number of parameters, a resistance, an inductance, and a capacitance. and two states, the inductor current, IL, and the capacitor voltage, VC. So there are also right there the differential equations that describe how this dynamic system behaves. Going back to the content of the DSAnalysis folder, in the code folder, we have all the subfunctions that are automatically called by the main file and by its functions. There is also a DDE stability folder, which is concerned with the calculations of characteristic roots of delayed systems. The files in this particular subfolder have not been written by me. They are written by Professor Wim Michiel's team from the Computer Science Department of KU Leuven. In the Systems subfolder, we have different types of systems. We have an MMC system, a net or network system, and an RLC system. Inside each of these folders, there can be multiple instances of one given system. For instance, if we go in there, in the MMC, we have instances called CCC for circulating current control. 1 pH is one phase, so single phase MMC with a circulating current controller, a single phase MMC with delays and with the circulating current controller, and likewise for three-phase systems without delays and with delays. There is also a file here which contains all the data for the MMC system, and each of the instances here will be relying on this data file to obtain all numerical values. I will naturally get back to this. Going back to our simple RLC system, I have defined only one instance, which is called chapter 3. We find the data file related to the RLC circuit, and inside this chapter 3 folder, we have 4 Matlab files. There is one file called EQNS, which stands for equations, which implements the differential equations of the system. There is a file called HD, which stands for harmonic domain or harmonic data, which contains the harmonic spectra of input variables as well as initial guesses for unknown states and delayed variables. A third file is called U of t, which is essentially the inputs written as a function of time. This is used for numerical integration, or otherwise stated, the time domain simulations. And lastly, we have a file called VARS, which stands for variables and which lists essentially all the input, states, delayed, and output variables related to this given instance. Every instance of a given system will start with these 4 files. So going back to our MMC, single phase with circulating current control, it has naturally a different name. The naming is always the same. We first have the name of the system, and then the name of the instance, and then the name of the function or script. Again, the 4 same files: equations, harmonic data, inputs as a function of time, and the lists of variables. So for our particular example, the simple RLC circuit, we will open the different files and see how they are structured. So this is the data file. I'm now opening the 4 other files.